So our solution is to apply the substitution x is equal to cosine theta. And then now let's talk about the second method to integrate the inverse cosine of x dx, where x goes from -1 to +1. Now in the previous video, I already talked about how to solve the integral of inverse cosine of x dx from -1 to 1 using integration by parts. And the second method here is to apply some trigonometric substitution. And I will go, and then I know what you guys thinking, that this is not possible using trigonometric substitution, because you think that trigonometric substitution is just basically use the substitution either sin of x, tangent of x, or secant of x. Well, you are wrong. That's because trigonometric substitution in simple terms is just apply the substitution that involves trigonometry, which means you can apply the substitution either x is equal to sine of theta, or x is equal to cosine of theta, or x is equal to tangent theta, or x is equal to cosecant theta, or x is equal to secant theta, or x is equal to cotangent theta. It can be any as long as it's related to trigonometric using substitution. So for this one, it's not suitable to use the x is equal to sine theta. But instead of using the inverse, instead of using the substitution x is equal to sine theta, we can use x is equal to cosine theta. That's because if I have x, if I let x is equal to inverse cosine, if I let x is equal to cosine theta, then this means that I have inverse cosine of x, which will result equal to x, right? So our solution is to apply the substitution x is equal to cosine theta. And then dx is equal to negative times sine theta d theta. And then theta is equal to inverse cosine of x. So by using trigonometric substitution, this thing is equal to negative times the integral of theta times sine theta d theta. And then what about the lower limit, upper limit? We can use the substitution to do it, right? So when x is equal to 1 for cosine, when x is equal to 1, it is going to be equal to 0. While x is equal to 1 is going to be equal to pi. So now, since we got negative, because this is an indefinite integral, we can switch the lower limit up by an upper limit, and then to exchange that we have to sacrifice the negative sign. So this thing is equal to the integral from 0 to pi of theta times sine theta d theta. And then we will apply the integration by part, because we got the polynomial times the trigonometry, and this for sine theta is going to be easy to integrate, but theta is easy to differentiate because we can just keep differentiating until the differential column has 0. So let's apply the integration by parts. So the d column, the I column, so plus minus, now theta, and then sine theta, and then the derivative of theta is equal to 1. And then the integral of sine theta is equal to negative cosine theta. Then we'll do another one again. The derivative of 1 is equal to 0. And then the integral of negative cosine of theta is equal to negative sine theta. But how you're going to do this is this multiplied by this, and then this multiplied by this, plus the integral of this. And then essentially we no need to do the integral because because when we multiply the row, we have 0 times negative sine theta, and then we are integrating 0 d theta from a lower limit to upper limit. So we can conclude that we no need to solve this integral because the integrand is equal to 0. So this thing is equal to, this integral is equal to, so negative theta times cosine theta plus sine theta from negative 1 to 1. So this thing is equal to, so from 0 to pi. So negative theta times which is equal to negative pi times cosine of pi plus sine of pi, and then minus 0 times cosine 0 plus sine of 0. Now cosine of pi is equal to negative 1. Negative 1 times negative pi is equal to pi. Sine of theta is equal to 0. 0 times cosine of 0 is equal to 0. Sine of 0 is equal to 0. So our answer is equal to pi because because the rest of it is just going equal to 0. And this is the second method to solve the integral of inverse cosine of x dx from negative 1 to 1. I hope you guys enjoyed this video. If you enjoyed the video, leave a like and subscribe to my channel for more upcoming math videos, and I will see you guys next time.